Hey guys, and welcome back. So today we're going to do an interactive activity and possibly with a partner where we're going to start investigating Newton's second law. So Newton's first law tells us that when forces are balanced, that the object's motion won't change, it won't accelerate, in other words. And if forces are unbalanced, in other words, there's a net force acting on the object, then the object is going to accelerate. So we know won't accelerate versus will accelerate. What Newton's second law is all about is understanding what factors affect the acceleration of an object. And today's experiment is going to allow us to investigate two factors which might have an impact. So we want to see how does changing the amount of net force acting on the object affect its acceleration, and how does changing the mass of the object affect its acceleration. And I think you probably have some ideas already about how that's going to go. But we want to be very specific about what types of relationships are present. And that's really what this experiment is all about and going to allow us to do by measuring and taking some data. So I want to show you the activity that we're going to do. You're going to want to open up the lab sheet that goes along with this. And you're going to also want to open up the actual interactive simulation. And then you'll be able to collect the data. I'm going to show you how to collect the data. And then you'll be able to do the activity by following the same exact steps. So I'm going to switch my view over here. Okay, so over on the left, you can see this is the lab sheet that comes with the experiment. It has some of the data filled in for us, as well as some information about it. In the middle here, I just put in a calculator just so we can do the calculation if we're going to need the acceleration. I'll show you how to do that. And then we also have the actual simulation here. Let's just push it. Okay. So we will work with a partner if we'd like to. You can work on your own if you like. But what we're going to do is we're going to have this block in the simulation, and it's going to be on a frictionless surface. So we're going to make sure there's no surface friction. So if we think about forces acting on the block, here's the force of gravity pulling it down. We have the support force from the surface pushing up on it, we call it the normal force. And then there's going to be an applied force pushing it. Okay, now since there's no friction, think about it like this. Gravity's pulling down, but the surface prevents it from falling down. Those two forces balance each other out, and all we're left with is that applied force. So that's going to be our net force in each of these. So to run this, I'm going to click on the start in the actual simulation. It's going to open up here. And I want to follow the lab sheet that's over here on the left. So I want to set it to have an applied force of 10 newtons. I want to make sure there's no surface friction for all the trials, and that's what it's at here. Okay? And we want to have the mass to be 2 kilograms. So I'm just going to click the up arrow here. So we have the object here. You can see the hand there that's going to push it. And it's going to continually apply the force. So when I click push, down at the bottom, it's going to graph the velocity. That's how fast it's moving in meters per second versus the time. So let's see what happens here. Click it, and we can see it speeding up. It's getting faster and faster, and the velocity is increasing, like we saw. Okay, so in order to see how the force and the mass are going to affect it, we're going to have to go through these trials. So what I want to do is first I want to type in the net force here. You can write it if you'd like. Fill it in, however you want to do it. I'm going to type it in here. So the net force here is 10 newtons. So I put that there. Okay, now where it says velocity time information, what I'm going to do is I'm going to pick 2 points on this graph. Because as you can see down at the bottom here, to get the acceleration, I need to take the slope of the velocity versus time graph. Because if you think about it, acceleration is how velocity changes over time. Well, the slope of this line would be how the velocity is changing over time. So I'm going to pick 2 points on the graph. So I'll click on this one, for example, and it gives us their coordinates. So 1 second and 5 meters per second. So I'm going to put that there. I'll just put the numbers. So 1, 5, and I'll put some space, And then we're going to pick another point on the same graph. And I have 4, 20. 4 seconds and 20 meters per second. So I recorded that information here. Okay, so to get the acceleration, I need the slope. Remember, slope is rise over run. So you're going to do y2, which is 20, minus y1, which is 5, over x2, which is 4, minus x1, which is 1. All right, so I'll take that into calculator here just so you can follow along, but a lot of you might be able to figure it out in your head. It's a pretty straightforward number. So 20 minus 5 gives me 15. That's the top of my fraction. That's the rise. And then the run is 4 minus 1. So that's 3. So rise is 15 divided by run, which is 3, gives me an acceleration of 5. So I'm going to put that here. That's the slope of the line. So for each trial, you're going to follow along by setting up the data just like it shows here. So we change the applied force to 20 newtons. So in this case, check out what's happening. We're doubling the applied force, but we're keeping the mass exactly the same. And then we're going to fill out the table. We're going to go through all the different trials here. And by getting all of those trials, we'll be able to understand much better how does changing net force or changing mass affect the acceleration of the object. So your goal for today is, whether you're working with a partner or not, is to get all the data in this table filled out and then uploaded to Canvas to be turned in. And then we'll work on analysis in another class.